Hello, this is my video for my fluid mechanics project for this pipe with glycerin flowing through it. Here are the specifications of the pipe here. I started with the continuity equation and its steady state and one-dimensional, which allowed me to cancel out most of that. And then I moved on to the Navier-Stokes equation and steady state, continuity, one-dimensional flow. No gravity in the x direction. This is again from continuity, and then the pipe is wide relative, and that allowed me to cancel it down here, and then solve the differential equation. Use my boundary conditions, which is just no slip at the bottom and top walls. Here the belt is moving, and then that gave me my final analytical solution. And then I moved on to the volumetric flow rate. I used this equation, dq is equal to velocity dA. And then I was able to set up a new integral, integrated that to get this. And then my average velocity was just the volumetric flow rate divided by the cross-sectional area. And then for the shear force, I used this equation for tau and multiplied by the area of the surface, which was length times width. Then here was my formula for the finite differencing equation. I just plugged in the second derivative and then rearranged to solve for Vxn. And then moving on to the Excel, I then plugged that in, and then with iterative calculation, it'll eventually reach very similar to the analytical solution. Here are my parameters here. The analytical, I walked through that. Numerical is very similar. Sum those times width, just the maximum here. And then I found the y value. Yeah, very similar. Shear force calculations were slightly different, which makes sense because my delta y wasn't like super large. It was good enough to get close. Reynolds numbers are very close. And then here is the COMSOL. I don't have that on my computer, but I can walk through that in a second. But again, they're very similar, not exact, but very close. They're all kind of in the same ballpark. Over here is the velocity profile. Here's the analytical as a line, and then numerical and COMSOL data points plotted on top of it. They're a pretty good fit. They're almost exact, I think. Here's the COMSOL page. I have 4 velocity profiles. These 3 were developing, and this one was fully developed. You can see that here. But to set up that COMSOL, you would just specify your rectangular, you put in your dimensions and your density and your viscosity. Then you specify your boundary conditions for no slip at walls, and the bottom wall will be moving. And then you would use the average velocity for the inlet velocity. And after you specify all that, you would build the mesh, compute, and then you would run some post-processing to get like this data. These were from slices that you can make, and you can graph where you slice. And then the shear rates came from line integrating at the belt and at the top. And that's everything. Let me know if you have any questions. Thank you.